Greetings. My name is Scott, and today I'm going to teach my 6-year-old daughter how to do algebra. The laundry's done. That's what that buzzer was. The dryer's finished.
Daddy, what's that?
That's the word pumpkin. You see, today we're gonna talk about the pumpkin patch problem. And to do that, I'm going to have to change the view of the camera around.
Daddy, what's that letter?
That word, that's an M. And I'm going to try to teach my daughter algebra. She's probably not going to get it, but it'll be a good start. And maybe you, if you're 11 or 12 or 13 or even 25 years old, might gain something as I fumble through this. So here we go. All right. So as we see here, this is the pumpkin patch problem. And we have a farm that grows 360 pumpkins, and they sell the small pumpkins for $3 and the big pumpkins for $7. And they sell a total of
60.
No, they sell $2,180 worth of pumpkins. Now the question is, how many big pumpkins did they sell and how many small pumpkins did they sell? Well, right away, we've got a nice little equation that we can write. And what is that equation? Do you know?
No.
Does anybody know?
No.
Well, we can say that the small pumpkins that we sold, we can say we sold X small pumpkins. Now, small X is a number that we don't know what it is. And we sold Y large pumpkins. Okay? Y is another number that's different than the other number that we don't know. Of course, they could both be equal, but we don't know yet. And we also know that X plus Y equals
100.
No, it equals 360 pumpkins.
I was close.
Right?
It was close.
360 pumpkins. Now we also know that we sold that if we multiply $3 times X, that would be the total amount of dollars of X pumpkins that we sold, of small pumpkins. And if we multiply $7 by Y, because Y is the total number of large pumpkins that we sold, if we multiply that by $7, then we know that that's how many dollars of large pumpkins that we sold. So now we also know that, and we can just kind of put these two together, and we can say that 3x plus 7y equals, do you remember over here? What's that number? That's 2,180.
I was going to say that.
I bet you were. So there, now we have this equation that tells us that 3x plus 7y equals 2,180. Now, I could go through all the trouble. So let's just do it. Let's just do something to this little equation right here. Let's just say that. Let's just come over here and let's just say that y equals 360 minus x, because we can always add if we're gonna. So just like if we have 5 plus 5 equals 10, if we subtract 5 from this side and we subtract 5 from this side, then we know that 5 equals 5, right? So we can do the same thing. Yes, it does. So we can do the same thing with these, because these represent real numbers, even though they're not fixed in any particular time or place. But we can just take the x and we can subtract x from both sides, and then we can end up with y equals 360 minus x. Now, if we take this equation right here, the 3x plus 7y equals 2,180, I could solve this whole equation for y, and then we would end up with, of course we know that y equals y, right? So if we solve this whole equation for y, and we've solved this equation for y, then we know that this part right here is going to be equal to whatever we set this to when we solve for y here, because y equals y. So, since I just proved to you, beyond a shadow of a doubt, I believe, that y equals y, well, guess what I'm going to do? I'm just going to take what I know to be y over here, and I'm just going to plug it right into that value there. Sorry for the blurry shot there. So I'm going to say that 3x plus 7 times 360 minus x equals
Nothing.
2,180, right? Right? So there's the equation that we need to solve now. And this now is just a matter of moving stuff around, multiplying stuff out, and solving it. And I can just do that real quick. Okay, so we get 3x plus 2,520 minus 7x equals 2,180. Now I'm just going to go ahead and subtract 2180 from this side, and I'm going to subtract 2180 from that side, and then I'm going to add 7x to this side, and add 7x to this side, and let's go ahead and subtract 3x from this side, and subtract 3x from this side. And that's going to give us 2520, I found my calculator, 2520 minus 2180, which is equal to 340. So that's 340, which then equals 7x minus 3x, which I don't need a calculator for that, and it equals 4x. Now, we can do the same thing where we can divide both sides by 4. And 340 divided by 4, 340 divided by 4 equals, that's right, it equals 85 equals x. So now we know that we had 85 small pumpkins, and it's a very simple matter to say, well, we had 360 pumpkins, so 360 minus 85 equals
Nothing.
equals 275. So when we plug 85 into here, then we end up with y equals 275. So at the end of the day, we had 275 large pumpkins, right? And we had 85 small. And that's how you solve, come here, that's how you solve an equation. Come here and look. Come here and look. Isn't this neat? And that's how you solve a system of two equations. And that's how you show all your work when you do it. Say thank you, Daddy, for teaching me algebra.
For teaching me algebra.